Hello 7th graders, and welcome to lesson 4.2 on constant rates of change. Remember, a constant rate of change is a rate that describes how one quantity changes in relation to another quantity. Many real-world situations can be described by proportional relationships. Proportional relationships have a constant rate of change. All right, let's look at the first example. A giant tortoise moves at a slow but steady pace. It takes the giant tortoise 3 seconds to travel 10.5 inches. First, let's set up a ratio or a proportion to represent this. So he travels 10.5 inches in 3 seconds. All right, we're going to use this bar diagram and the proportion that we made to find out how much he'll travel in 1 second. Remember, this is kind of like our unit rates from 4.1. Anything with a rate per 1 unit is going to be a unit rate. So we want to know how far he'll travel in 1 second. Remember, one of our strategies there was to just solve this fraction or division problem. So what operation are we going to do to find the answer? We're going to divide. We're going to do 10.5 divided by 3, which is 3.5 inches. So the tortoise travels 3.5 inches per second. All right, let's use that information to complete the table. First, we know he travels 3.5 inches in 1 second. Now, to get from 1 to 2, we multiply by 2. So we're going to multiply 3.5 by 2, and he travels 7 inches in 2 seconds. And let's look at the next box we have to fill in. It is 4 seconds. How far does he travel? We're going to use this proportion to get there. How does 2 get to 4? Multiplies by 2. So now we're going to take 7, multiply by 2, and he travels 14 inches in 4 seconds. And then to get this last box, we're going to use the constant rate of change. So how much is this increasing every time? Each second he travels 3.5 inches. So that means each new box, the seconds increase by 1 and the inches increase by 3.5. So from 14 inches, I can just add 3.5 and get 17.5 inches, because that 3.5 inches per second is my constant rate of change. All right, so let's reflect on this a little bit and make some educated guesses. Suppose the tortoise travels for 12 seconds. Explain how you could find the distance the tortoise travels. Well, we know the tortoise travels 3.5 inches per 1 second. I want to know how far he travels in 12 seconds. I could just multiply 3.5 times 12 to get that number, which is 42 inches. All right, so how would you describe the rate of speed at which a tortoise travels? Well, he travels 3.5 inches per second. That unit rate is also his rate of speed. All right, moving on. Proportional relationships. A rate of change is a rate that describes how one quantity changes in relation to another quantity. A proportional relationship between two quantities is one in which the rate of change is constant. So a proportional relationship has a constant rate of change. When we set up these different proportions in the same relationship, they will look like equivalent fractions or equivalent ratios. All right, let's look at the first example. Callie earns money by dog sitting. Based on the table is the relationship between the amount Callie earns and the number of days, a proportional relationship. Well, let's see. The first ratio, she works 1 day, she earns $16. We're going to use that unit rate, $16 a day, as our constant rate of change. Let's see if it works for everything else. In 2 days, she earns $32. As times 2 times 2, we're good so far. In 3 days, she earned $48. So now we check, is 3 times 16 48? And it is, we're good. All right, next one, in 4 days, she earned $64. So now we check, is 4 times 16 64? And it is, we're good. And last but not least, in 5 days, she earns $80. Now we're going to check, is 5 times 16 80? And it is, we're good. So all the rates are equal. there is a constant rate of change, which means this relationship is proportional. That constant rate of change is $16 per day. All right, so now it's your turn. Pause the video, see if you can do number 3 on your own, and then play it back to see if you got it right. I'm going to go ahead and solve problem number 3. All right, the table shows the distance Allison drove on one day of her vacation. Is the relationship between the distance and the time a proportional relationship? Did she drive at a constant speed? Explain. Okay, so in 1 hour, she traveled 65 miles. Now, if this is a proportional relationship, that's going to be our constant rate of change since that's our unit rate, which means I can check all of these other boxes by multiplying the hours times 65 miles and checking if it still fits our proportional relationship. So next one, let's check, is 2 times 65 120? And it is not. 2 times 65 is 130. So this second box does not fit the constant rate of change. So this is not a proportional relationship. All right, next example. 2 pounds of cashews shown costs $19 and 8 pounds cost $76. Show that the relationship between the number of pounds of cashews and cost is a proportional relationship. Then write an equation for the relationship. All right, so we are going to set up ratios and then see if they're equivalent. So 2 pounds is $19, 8 pounds is $76. To get from 2 to 8, we multiply by 4. And let's see, is 19 times 4 76? And it is, so that is a proportional relationship. 2 19ths is equal to 8 76ths. So now that we know the rates, we need to write an equation for the relationship. To do this, we are going to find the unit rate, or we're actually going to find the cost per pound. So I know 2 pounds cost $19, or $19 per 2 pounds. And now remember, to find the unit rate, we can actually do that division problem. So 19 divided by 2 is 950, which means the rates are all equal to 950 per pound. Constant rate of change is 950 per pound. Relationship is proportional. All right, so now we know how to solve it. If you are phrasing this for, say, a quiz or a test, and it says write an equation for the relationship, you would say the cost equals 9.5 times the pounds. So when you're writing an equation for the relationship, you're showing how one variable relates to the other. We're showing how cost is related to the number of pounds you buy. Cost is going to be 9.5 times the number of pounds. All right, to numbers 2 and 3 at the bottom of page 126, it says find the constant of proportionality k, then write an equation for the relationship between x and y. So remember, to find the constant of proportionality, I'm finding the unit rate. In this case, it looks like y is bigger, so I'm going to find the unit rate for x. So when I have 1x, set up a ratio to find that. 10 over 2 equals y over 1, or what over 1. 10 divided by 2 is 5. So y is 5. So when we write our equation for that, we're going to say y equals 5x. Our constant of proportionality, k, is 5. All right, pause the video, see if you can do number 3 on your own, and then play it back to see if you got it right. All right, I'm going to go ahead and solve number 3. We're going to find the constant of proportionality in terms of y now. So we're going to set up our ratios, and we have 8 over 2 equals x over 1. 8 divided by 2 is 4. So k equals 4. All right, how we write this equation, we're going to say x equals 4y. Now, if you're unsure which variable the constant of proportionality, or k, goes next to, it's a really good idea to double check your answers. So if we plug in 2 for y, 4 times 2 is 8, so I get the right x value. Same thing for number 2. If I plug in 30 for y, 30 is equal to 5 times 6, which is x, so we're good. All right, your homework today is on page 127. It's to do numbers 5, 6, 7, 9, 11, and 12. Email me if you need any help.